Good evening, ladies and gentlemen. My topic for tonight will be the so-called reverse polarity protection for sensitive electronic gadgets. If we try to power up electronic gadgets, usually there is the positive terminal or negative terminal and positive terminal of the power supply. We try to clip this one to the negative terminal of the gadget, and we clip this one to the positive terminal of the electronic gadget, of course with the specified voltage. But sometimes there are two terminals available, and if you are absent-minded sometimes in the so-called connection, you might connect this one to ground, and you connect the ground to the positive terminal. So if the gadget is so sensitive with the reverse polarity, it might be damaged. So what I did tonight is I tried to assemble the bridge circuit. Bridge diodes actually consisted of single diodes. This is diode number 1. This is diode number 2. This will be diode number 3. And this will be diode number 4. So what I did is that to avoid the so-called reverse polarity in the connection, okay, the connection points of the positive and negative terminals are this one here, this one. It's not this one. It should be this one. So with this configuration, if we try to connect the plus here and the minus over here, if this is plus, this will conduct, current passes through here, it goes to the positive terminal of the load, the one with the red thing. Of course, it goes to the load, the current goes to the load, then it goes back to the ground terminal. So this will be the ground terminal. It goes back here. Okay? And this diode will conduct, then it will go to ground. You got it, guys? If this is plus, this should be the ground. That's how the current will pass through. It passes through diode number 1, it goes to this, it goes to the load, it goes out to the negative terminal, it enters this junction here, okay? Then this diode number 2, number 2 will conduct, then the current will go to ground. That's the complete path. If this is plus and this is minus. Supposing you interchange, you connect this one as plus. So if this is plus, diode number 3 will conduct. This diode number 3 will conduct because this is anode, this is cathode. Anode to cathode, okay? If this is plus, this will conduct. So the current will pass here. Again, it will go to the plus terminal of the load. It passes through the load. It goes back here. It enters this junction. But instead of entering this one, okay, it will enter diode number 4. Diode number 4 will conduct because this is anode, this is cathode. Okay, current could pass through here. So the ground current will pass through diode number 4, then it goes to ground. That is, if this is plus, this should be ground. So in both polarity, the direction of the current passing through the load is actually the same. Okay? I will repeat it. If this is plus, this will conduct. Okay? The current will go to the load. It goes back. Then it passes through this diode here. Then it go to ground. Supposing we reverse the polarity, if this is plus, this diode will conduct, okay? It passes here, this junction here. It goes to the positive terminal of the load. It passes through the load. It goes back here. Then it goes to ground, meaning to say this diode will conduct because this is anode, this cathode. This will conduct. Then it goes to ground. So that's the sequence. So for both what you call this condition, the current will always pass through this terminal here. It goes to the positive terminal, then it goes back to ground. So even though this is plus, okay, the current enters here, it goes through the load, then it goes back here. If this is plus, okay, this will conduct, it enters this junction here. It will pass through the load, positive terminal, negative terminal, then it goes back, then it goes to ground. That's the sequence. So even though you interchange the location of the plus and minus terminal, since the circuit is actually a bridge circuit, the current will always passes through the load in one direction. So there is no such thing as reverse polarity. We'll try it. Okay, I set the voltage now to 6 volts. Okay. First condition, if I will put the plus here, okay, then I will put the negative terminal here. It works, right? It works. So meaning the polarity is correct. Okay. On the next condition, if I will put the plus here, okay, then I will put the minus here. Still the gadget operates, meaning to say even though we interchange the polarity, the gadget still works. So that's the so-called polarity, reverse polarity protection. Okay, even if you reverse it, okay, the gadget will still operate even though you interchange the polarity of the terminals. I will repeat it. If this was plus, okay, and this will be minus, that's minus, the gadget operates, right? That's the first condition. If I will change location, if this will now be plus, okay, and this will now be minus, still the gadget operates. So you see it, guys? Even though we interchange the location of the plus and minus, the gadget still operates. So even though maybe you are absent-minded in the connection, for as long as you use these two terminals here in the connection, okay, the gadget will still operate and it will not be damaged. Oh, that's the so-called reverse polarity protection. With this connection here, when this is plus and this is minus, the gadget operates. But when this is plus and this is minus, still the gadget operates. So it doesn't matter. In which you will connect the plus and minus as long as you use this terminal here. Don't use these terminals. That will be a different story. Okay? That will be a different story. So for the reverse polarity protection, you use these two terminals here. First condition, if this is plus and this is minus, the gadget operates. And if this is plus and this is minus, still the gadget operates. So no matter how you connect it, okay, the gadget will not be damaged due to a reverse polarity. Good evening from Los Angeles. This is Professor David J. De Los Reyes.